So if we have a wall, we got a ladder put up against the wall, like this. Do a different color. This distance from the base of the ladder to the wall impacts how high up we can reach on the wall, right? So if you were to pull the ladder away, so make the base distance even further, like this. Oh, I didn't mean to make that red. There we go. Then you've shrunk how far it is up on the wall, right? They're related to one another. So they say they have a 15-foot ladder. It's leaning against the wall. If we put the ladder away from the wall at a rate, if we pull the ladder away from the wall at a rate of 2 feet per second, so this distance here, the ladder is moving in this direction 2 feet per second. So how fast is the top of the ladder moving down the wall? It's here, then we pull it further away, so it's here. Oh man, I can't draw with this thing. And then we can pull it further away, and it's here. It's getting further and further away. As it gets further and further away from the wall at 2 feet per second, the height it reaches up in the wall is getting lower. So we need to put some variables in here. That way we can construct an equation based on the situation. Then we can use implicit differentiation, all that fun stuff. So why don't we call this D? I just drew here this orange distance D. It's constantly changing because it's constantly increasing by 2 feet per second. So here I'm going to write that D prime is equal to positive 2 because this is increasing 2 feet per second. So the distance from the base of the ladder to the wall is constantly increasing by 2 feet per second, so we say D prime equals 2. Then we'll call this H. This is the height that the ladder reaches, and assuming that it's not the Leaning Tower of Pisa, however they say it, D squared plus H squared must always equal 15 squared, because no matter how you draw that triangle, it might get more narrow, but it's always making a right angle. So the Pythagorean Theorem gives us this equation. So how fast is the top of the ladder moving down? We want to know what H prime is. Okay? And H prime should be negative because if we're moving 2 feet away from the wall, we're getting pulled further and further away. So H is decreasing, right? So in order to find that out, we need to use implicit differentiation. I can take the derivative of both sides. So this is 2D times D prime plus 2H times H prime, and that should equal 0 because the derivative of a constant. And we have that D prime is 2. We need to know what D is and what H is in order to solve this equation. They tell us that the bottom of the ladder is 12 feet from the wall, so that means D equals 12. D prime, we're told, is 2. It's a constant 2 feet per second. Now H we don't have, but you could get it really quickly by plugging it into the Pythagorean Theorem equation that we created. So distance squared, got 15 squared minus, okay, it looks like H is going to be 9. And again, I got that because I plugged in 12 into this equation and quickly solved for H. And now I have something to solve for H prime. So this is 48 plus 18H prime equals 0. So 18H prime equals negative 48. So H prime as a fraction. 2 2/3, so that's 8/3, negative 8/3. They want positive 8/3 for an answer. How fast is the top of the ladder moving down the wall? I guess if they're saying moving down, it's moving down 8/3 units per second. But if the question was how fast is the top of the ladder moving on the wall, then negative 8/3 would be the right answer because negative specifies the direction. They said how fast is it moving down. They've already taken care of the negative sign for us in the explanation of the answer. So it's got to be positive 8/3, not negative. Okay, there's a radio tower. And the man is 12,000 feet from that radio tower. We got a plane poorly drawn in the top right corner here, flying 500 feet per second away from the man. So that's why I drew the arrow going this way. And they're talking to us about the distance between the man and the airplane. We'll call that D. They want to know what's the rate of change of D. How fast is the rate? How fast is the distance between the man and the plane increasing? So they want to know something about D prime. So think about things that fluctuate first, because you want to construct an equation for all the variables in the problem. Everything that could possibly change, you want to make an equation for it. And then once you have that equation, you can differentiate the equation and plug in the particular information. So let's look at all three sides of the triangle. The distance the man is from the plane, that fluctuates with respect to time. As time goes on, that distance increases. This distance between the plane and the ground, that actually stays the same irrespective of time. You know, you go 10 seconds, 100 seconds, the plane is holding a constant elevation of 5,000 feet. So that is not a variable. Down here, I put in 12,000 because at the particular instant, this person is going to be 12,000 feet from the base of the radio tower. But this also changes with respect to time. In fact, this part right here, well, I don't know, we'll call this X, that does change. It needs a variable because it changes at 500 feet per second. We know that X prime is going to be 500. So I think that's probably one of the hardest parts of these related weights problems. You got to first make an equation with variables. Anything that could possibly fluctuate with respect to time needs to have a variable. And then you can go back in and plug in this information as you attempt to solve. Okay, so we need that equation with variables. And we can use the Pythagorean Theorem to relate these three things to each other. X squared plus 5,000 squared equals D squared. Sorry about the dog in the background. And we're looking for D prime, so we want to look at the derivative of this equation with respect to time. So differentiate each term with respect to time. You need implicit differentiation. So this is 2D times D prime. And now we have particular information that we can plug in to help us solve for D prime, right? We know that the distance between the man and that radio tower, the distance between where the plane is, is 12,000, so that goes in for X. X prime is 500. And D, actually we don't have D yet, but we could get it really quickly, because D at this particular instance is determined using the Pythagorean Theorem. 12,000 plus 12,000 squared plus 5,000 squared equals D squared. So with my calculator, 12,000 squared 5,000. Maybe I'll get lucky. Yeah, 13,000. So D equals 13,000. So at this particular instance, D equals 13,000. And now you just have an equation to solve to get D by itself. D prime, I should say. The rate of change of the distance the person is from the plane, you know, that diagonal distance, is going to be 2 times 12,000 times 500 divide, oh, is that 500? Yeah, it's 500 because D prime. Okay, X prime, I should say. Divide by 2 times 13,000. And the rest of that's just algebraic simplification.